Hi, everyone. Welcome again to another session on GraphQL architecture with us here at StepsN. We're happy you're here. Today, we're going to be talking about designing for scale. And as always, it's going to be your host, me, is here again. And today we've got Sridhar with us, our CTO here at StepsN, who's going to be driving a lot of the content. Just a little bit about me. I've been with StepsN since the early days here, a few years. Prior to that, I spent time in Google and Apogee. And previously to that, I was at a pretty large retailer, Fortune 50 size company. And obviously, I guess in my own experience with scaling, I ran into lots of fun times around Black Friday in the retail world. Is an interesting time for all sorts of systems. So I think I'm looking forward to this talk today. And Sridhar, why don't I hand it over to you?
Thanks, Carlos. I'm Sridhar. I'm CTO here at Steps, and I've been building systems that are large in scale for a long time. I too was at Apogee before Steps, and I'm excited to be here today to talk about some of the things that I really like to talk about and represent a lot of accumulated knowledge from many experiences that sometimes we got right and other times got wrong. So Carlos knows what I'm talking about as well. So back to you, Carlos.
Yeah, so if we hop to the next slide quick, we can see our agenda for today. And I think one of the things you just said, Sridhar, jumped out at me in terms of experience. And I think with scaling, the experience is really invaluable. It's very hard to anticipate and understand everything that you run into. So I'm looking forward to hearing some of the things that you bring up today. So just at a high level, we're going to talk about what does it mean to scale. And I think you've got some interesting insight to share there. And then we'll talk about designing for scale. Once we kind of understand what it means, let's talk about how we design for it and considerations and such. And then we should have plenty of time at the end for some questions. So please get those ready and let us know what's on your mind at the end. So Sridhar, take it away.
Perfect. Thank you, Carlos. So what does it mean to scale? I'm trying to explain it relatively simply, and it means different things to different people. But in our context, in the context of steps, and it means specifically what happens to things like latency, throughput, cost, when usage, which is our traffic, the number of developers that are using our system, the number of endpoints, GraphQL endpoints that we are hosting, or the complexity of the queries that we are experiencing goes up or increases over time. And right at the beginning, I want to make a difference between scaling and auto scale. In auto scale, you want to think about what happens when your usage either increases or decreases relatively quickly. So the idea here is that you're not really changing anything. It is some kind of automation that's kicking in and making sure that your service is provisioned well enough to keep up with the demands that are being placed on it. Another way to think about the difference between scaling and auto scaling is that you're on some kind of curve relative to how much traffic you have in terms of costs or throughput or latency. And auto scaling makes sure that you're moving along that curve at the right time, right? So move us to the left or the right depending on what the actual traffic is, and so you can track that curve. Whereas scaling is about bending that curve and making it better for the service. So decrease cost, decrease throughput.
Okay. So that's interesting because, and I'm going to reveal a little bit about my age. But one of the things that I used to worry about in past lives was max capacity or max throughput and it was especially in the situation of retail when you get very large seasonal spikes. Back when I was doing this, the auto scale thing was just it was relatively new, or didn't exist at all. So a lot of the work that went in when we talked about scaling was, anticipating what the max load was going to be, running tests, and thinking about what you needed to provision ahead of time. And
Yes.
it sounds like auto scale sort of takes care of that because it automates the provisioning of things like that. But the scaling you're talking about, I like the way you said that, sort of bending the curve is rather than looking at it sort of a static situation of saying, oh, if we have 100 concurrent users, we need this much CPU and memory available, and if we have 10,000 concurrent users, the number goes to this. Instead, you're thinking about how can we make that 10,000 number actually be lower, and how can we design the system so that it doesn't have that same impact? Is that fair?
Absolutely. In a nutshell, that's exactly what thinking about scale means.
Okay.
Tools today, as you said, cloud-based deployments, tools like Kubernetes and so on, more or less address autoscaling. And it's important to learn how to use these tools, and they're not always easy to use. But if you use them correctly and well, problems that have to do with scaling up and down in response to short-term spikes can be automated, and you do not need to really work hard at making those things happen. But scaling is different and requires careful software design. And because it's really about improving the efficiencies of your system, making sure that you don't run into bottlenecks which prevent you from auto scaling. Another way to think about it is big buildings need to be designed differently. So if you have a huge building, electrical supply it needs is designed differently. The water supply is different, right, than you would need for a house. And it's really hard to retrofit, the electrical supply if it's not designed properly. And a lot of scaling is about making continuous improvements. So if you do go down a journey of having to scale a service, be prepared for the long haul. There's no single shot solution because it is really about building software correctly and improving things as you discover issues. And today we are going to focus on that second topic, which is how do you scale, not just how you auto scale.
Yeah. So another way to look at this, I guess, would be that today's solutions like Kubernetes sort of take care of the auto scaling, like you said, or even if you go into sort of a serverless infrastructure where you're using AWS Lambda or something like that, they will just give you as many as you need. But if you don't think about designing the systems to support that, you may end up maybe not necessarily over provisioning, but your service isn't going to fall down, but the amount of infrastructure you put behind that might not make sense, right?
Yes, and might be too expensive for your business to sustain.
Sure. Yep.
Yeah. And so scaling it requires much more careful thinking and upfront thinking to get right. One of the things I like to talk about is how do you design for scale. So the point of designing is you think about something before you do it, right? You think about it much more, and that's a very good practice, especially when you're building scalable services. You kind of work it out in your mind to see what are the things that could possibly go wrong and how you would respond to them. So a typical sequence of thought for me is these 6 questions. What are the axes for scale in our case? How do you measure the metrics? Which of the key metrics will likely break when you push out along each one of these axes? So the metrics are the things that break. So for in our case, latency, throughput, cost.
Mm-hmm.
And the axes I will talk a bit more about. And then how you address these breakages, how do you address these bottlenecks, what are the trade-offs you'll have to make? Because usually these are architectural decisions, design decisions. What are the trade-offs you'll need to make? And lastly, I always ask myself, what do I need to do now so that I can execute my plan in the future? So is there something that I have to do right away? Because otherwise I would be behind the 8 ball, so to speak, when the problem hits us.
And then this is something that you'd end up, like you said, it's a continuous process. So this isn't, you don't just do this at the start and you're done. As you make changes, you need to go back because the axis of scale might change, or the impact, what might break, might change based on what you do. So this is sort of an iterative process that you run through.
Yes, exactly. And in fact, what changes most often is the answer to question 3. Because you make an improvement and that pushes the bottleneck to some other place. And so something else will break, right? So you've solved your latency problem, but you've introduced a cost problem, or you've solved your cost problem and you've introduced a throughput problem, right?
So it's a little like a sort of a whack-a-mole situation. You push down on one thing and it pops up somewhere else, and you need to now think about that, right? So
Exactly.
having this sort of this rule set that you can run through gives you a nice framework for making sure you're not just randomly chasing your tail trying to solve problems.
Exactly right. And each time you do this, you are making improvements, because the next time the same problem comes up, which it will come up at a much larger scale than it did previously. So you're pushing the bottlenecks back. Right?
Yeah. So it's not just like the whack-a-mole analogy is probably wrong then, because really what you're doing, you are improving things. You're increasing the amount of whatever it is that you're trying to handle every time you make a change. You're just finding new spots where that extra load now becomes more visible.
Exactly right. Exactly right. And this is why it's an ongoing commitment, and it takes a while to get to something that is sustainable. As I said, one of the first things to talk about is what are the axes for steps in. These are not all of the axes that we think through, but here are example, and I think these are the most important ones. The first obviously is traffic, which is how many requests we get. We also have a lot of developers who work on Steps N, so the number of developer accounts we are servicing simultaneously is an important count. And each developer can create as many GraphQL endpoints as she wants, and so that the total number of GraphQL endpoints we are hosting and serving is an important number. We also have a global footprint, and so the number of global regions we serve is an important aspect of scale, right? Because that increases the complexity of what we are doing. Mm-hmm. And last but not at all the least, and perhaps one which gives us a lot of work that we do is the complexity of the requests. GraphQL, as you know, is a query language, and the queries can get more and more sophisticated. And as they get more sophisticated, the system that serves them also has to be engineered to be able to serve the more sophisticated set of queries. So as we improve our feature set, as we improve the kinds of things that we can do within Steps N, the needs of the infrastructure scales with that as well.
Sure. So if you weren't Steps N, right, your list might be different. If I'm just building a GraphQL API to support, say I have an application that has customers rather than developers or something like that. Number of customers that I'm servicing might be one of those things. I think traffic is probably always going to be there. Request complexity is, I think, a pretty important one. Maybe I'm not global, so that doesn't matter. Maybe I only have one endpoint that I'm keeping up there, but maybe I have, like I said, number of customers. Maybe I have different rules for access control, and the needs of that start to go up and impact things. So I need to kind of look at my system and think about the bits of scale that I know could have an impact, or is it more important to say these are important to us from a success perspective, right? Traffic obviously matters. I want to make sure that if I get a lot of traffic, I don't suffer.
Yes.
Number of customers matters. I want to make sure if I have a lot of those, I don't suffer, right?
That's exactly right. And you should also think about it from a whole system perspective, because if you're using GraphQL to expose data from a particular backend service, then the limitations of that backend service can also limit the extent to which you can scale.
Sure. Okay. Yeah. So if I'm connecting to a database, for example, right, I need to think about what number of connections that I have open is one of the things that I start to look at.
Exactly. So different people, different projects have different axes along which they have to ensure that they can scale. And your list would be different, but it's important to think through what your list is, and know upfront where things can break, right, in that list. And so that's the first step to designing for scale, is to know what it is that you're scaling.
Excellent.
So how do you measure your key metrics? I'm just going to show you a simple demo. As I said, we measure our key metrics using latency and throughput and cost. So for latency and throughput, we actually have we use an open source tool, which is K6, which is a traffic driver. We've made something available. If you look at our website and search through our blogs, you will also find articles about how you can use K6. But let me show you a very simple demo. It'll take hardly 20, 30 seconds. Can you see my screen, Carlos?
Yes.
Okay. So I've installed K6 on my laptop, and I'm just running K6 as a command line tool. It's not too difficult to run, but this is running requests against StepSend. And it's running GraphQL requests against StepSend. And as you can see, at the end of this, it tells me, for example, it was able to make 66 requests a second here. And it was, the average latency was 149 milliseconds. The min one was 111 milliseconds. And so I can measure latency. I can measure throughput. I mean, that's the point I wanted to make. And these measurements are from the field, so to speak. I'm right now at home. I'm also doing a live stream, right? So my network is pretty constrained. We do these measurements also from various points all over the world to see what the latencies are, what throughputs are, and we do it within our data center to find out what component we can assign to the network, what component we can assign to the compute. So we can do all kinds of important measurements. And as we do those measurements, right, you will see that you learn more and more about the system. If you ever use K6, I'd like to point out this line, which is the HTTP request failed, and gives a tick mark of 0 and a cross mark of 671. That means that the answer is no for 671 requests. So I got confused about this.
Oh, right, sure.
You have to remember to say that the cross mark actually means it succeeded. And right, because the bit
zero
is
failure is what that means.
That's exactly right.
That's a nice gotcha. So for this, as you were doing something like this, this is part of that continuous process. You would come up with different load profiles. So, for example, you just did one from your laptop that was 10 virtual users over 10 seconds.
Yes.
But depending on where you were, you could tune that to different load profiles or run it on more machines if you really wanted to push to see how things work. And then you would look at your auto scaling to see what the reaction was, right? To understand. We didn't even, we got to 1,000 concurrent connections and we're just handling it with one node. And when we get to 2,000 is when we tip over to this, we scale up, for example.
Exactly right. So we set up an entire test bench and we run it, and that helps us measure what our behavior characteristics are like. And it tells us things about our latency, our throughput, and our costs as well, because It tells us where we switch over to having extra nodes, what our maximum throughput per node is, and how much we are paying for those nodes, and so on. So
Yeah.
the best way to get a handle on the metrics is to actually measure them, and you should build a standardized benchmark that you use to measure all your metrics. Without that, it's really hard to work through a long term in terms of, it's hard to tell whether you're good enough or not.
Yeah.
Right?
Or the changes you're making are making a difference, right? And
Exactly.
like you said, it's an this is looking at one axis that we're measuring, which was request traffic.
Yes.
Requests per second or something like that. You may have something that's payload size that you start to run different loads on to see what that does. And it's you need to kind of push on that to actually see what the profile of the load impact is, so that am I bringing that curve down, or hopefully you're not making it steeper. But that's kind of the scaling that you're talking about. When you talk about shaping that curve, I'm saying, okay, now look, I made this change, and when we ran at 10, 100, 1,000, 10,000, this is what it used to look like, and now this is what it looks like, and it's
exactly right. When we measure query complexity, for example, we run simple queries, moderately simple queries, large complicated queries, and we run those things before and after the change to make sure that things are improving, right? Because otherwise, how do you know?
And so that's an interesting little, I guess, if we bring it to the world of GraphQL, that's kind of one of the interesting things about GraphQL, is because you can have that query complexity that's so different. It's not just a REST API where I'm getting the current conditions for a zip code from a weather, for example, which is kind of, it's almost the same thing regardless. Here I could be asking for any number of things and making that backend system have to do joins where maybe it wasn't. So that all matters.
Yes, it does. And it's important that you design your experiments so that you're measuring the things that matter. Right?
Yeah.
And that's why knowing upfront what your metrics are and what your axes are is very important.
Gotcha.
Let me go on to the next point. So I wanted to talk about a couple of examples, right, as opposed to describing everything that we do, because there are lots of things that we do, right, and there's no easy way. But I picked a couple of things that I thought would be illustrative of the kind of points that we have been making. So the first one is traffic, which is what you saw. And one of the thought experiments that I've been doing, which is after doing all these tests, to see what is most likely to break with increased traffic. So if I push traffic up to a very high level, and the test that you saw, which was 60 requests per second, is not even close to what I mean by increased traffic. We can do several thousands of requests a second.
Yeah.
What is most likely to break? And we know the answer to that question. I mean, in the sense of we have a good guess, which is that backend latencies will cause increased API latency. What that means is that the backend systems tend to feel the effects of high traffic earlier than step-end systems. Now, at this point, we could kind of rest on our laurels and say, hey, not our problem, right? But actually, we can do something to address it, which is caching to reduce load on backend systems. Because many times, queries ask for the same information. If you're asking 5,000 requests a second, it's unlikely that you're getting 5,000 fresh responses which have not come to us before. So one of the things we can do to address this is better caching to reduce load on backend systems, and that caching is somehow deeply tied to GraphQL semantics, so it knows, whether you're fetching the same record or not, and is able to optimize how it rewrites queries to make use of that. But beyond just caching, we can do other things as well, right? we can, in the case of databases, group multiple queries into a single query. So, as I said, there are many things that a well-designed, well-engineered system can do in order to address these problems, which at the surface looks like we are done, but
Hmm.
but a good system um, uh, can improve on the seemingly hopeless situation as well.
Yeah.
And and that's the reason why I said, this is about bending the curve. It's about building a system which is better than the system that you've already built, right? Something that does something differently in a way that solves a deep-seated, deeply rooted problem.
Sure. And I suppose I noticed, you talked about trade-offs, right? So with if you could spend, hours and hours of really deep engineering time solving how to cache every node in a GraphQL request. So if you see another request that sort of gets the same thing, we can serve it from a cache. But even then, there's costs of just operating that from a the cache memory of perspective, or if you're offloading to some other system, you've got to deal with that. And so it's not simply a technology decision at that point, right? There is a business aspect to thinking about how much optimization is enough.
is is enough, and how much optimization uh, is too much.
Yeah.
uh, and especially when you're making these multi-dimensional things, right? You've got to track both these dimensions. You've got to track the cost, you've got to track the uh, the value, which is how much you've reduced latency, for example, and you've got to find the right inflection point in that curve, right?
Hmm.
You've got to find the right inflection, and that is about making the right decision, having the right experiments in place, which is why this is very different from auto scaling, right? It impacts many things.
Yeah.
It's about scaling the business as opposed to just scaling the service. Uh, and what can we do now, right? Well, we don't know what parameters we'll be using for caching, for example, because that's a business decision. That is something that we'll only know when we have the particular workload in hand and so on. But we ensure that we have the correct knobs and switches in place, right? So we build so that we can be flexible in the future, right? And we can increase or decrease or tune cache sizes to match the demand curve and control costs at the same time, right? So it scaling in this case really turns into a way to design our systems to be flexible enough to be able to adjust to the operating environment that we're going to face in the future.
Sure. And that goes back to the point you made earlier about how it can be hard to change that architecture. The example of the big building versus the house, right? That's a
Yes,
hard change to make when you have the problem, but
exactly.
designing for it ahead of time makes that a lot easier.
Makes it possible, right?
Yeah,
It's
possible, I
sometimes
guess.
yeah. And that's the reason why I like this example. Uh, there are other things that also fit into the same bucket, and as I said, query rewrite is something that database engines have been doing for a long time,
Hmm.
and it's a sophisticated piece of technology that allows you to take a query and write an equivalent query that runs more efficiently.
Sure.
There's an equivalent for that in the world of GraphQL, and we do some of it, right? We do a lot of fairly interesting and deep query rewrites in terms of how we call our backend systems. We do this for things like pagination. Pagination is eventually an efficiency issue. We don't fetch data that we do not need because you're rendering page 22 in a sequence of pages. You don't need to know what was on page 21 and 23, and you can optimize your runtime a lot if you know exactly what data you need to fetch. So we do those sorts of things as well, right? But and they all address the same kind of problem with increased traffic. You try to reduce the load on your backend systems um, by doing very smart things in the GraphQL integration there.
Interesting.
Okay, let me go on to the next one. Uh, I'd like to talk about developer count, which is what happens uh, when uh, when we have a lot of developers, right? And again, we go through the same process. What is likely to break with increased developer count? Uh, and the answer is very different. Things that are likely to break are not necessarily technological, and that's the reason I picked this example, right? Account maintenance costs and questions on community channels and requests for account management, uh, right? And support. Uh, and the answer to how you address this set of questions also reasonably well known, which is, better self-service account management, better documentation, and in-product help, with tooltip help and things like that, and building communities and knowledge bases around communities. Uh, and so this sort of thing is also very important for scaling, right?
Mm-hmm.
And scaling is not all about bits and bytes. It's about the service, right? When you think about the service as a whole, and you're trying to scale the service, the kind of things that you have to worry about and be concerned about is how do you reduce the cost of running the service, and that includes being able to do things like this much more efficiently.
Yeah, I think the advent of the idea of multi-tenancy has kind of taken away from people thinking about the technological side of this problem. But it used to be that a lot of times when you had a new customer, you would spin up new solutions for them or new infrastructure anyway, right? Or if I'm
Yeah.
thinking about, if I'm building a GraphQL API for my service, nowadays we don't really think about, oh, I'm going to create a new endpoint for every customer I have, but that's kind of
Mhm.
how it used to be done. It was a new endpoint, new infrastructure that I would host.
Yes.
But there still is, this is interesting because there still is a scaling it's not like you said, it's not a bits and bytes concern, but it's an operation. I would call it just a general operations concern because it ends up being a people problem, right?
Yes.
And
Uh, and Carlos, it's very interesting you mentioned this because at the beginning it was a bits and bytes problem. Uh,
Mhm.
there was a time when, as you said, every time a new customer came in, you had to go provision something for them, right? Now that's no longer the case. In case of StepSend, for example, someone can come to StepSend and click on a button and get a free developer account instantly,
Yeah,
right?
and we
And
started that way. It wasn't we just kind of started multi-tenant, right? There was no
yeah,
that was an early on design decision, I guess is
it's
the
an
way.
early on design decision, and that enabled us to do this, right? And we thought that, hey, we've solved the bits and bytes problem, but no, we hadn't, right? Because this is something that we just spoke about a little bit earlier. That it's the whack-a-mole type thing, right? We've solved that problem, and the problem came up elsewhere,
Mhm.
but it came up much later down the curve than it would have come. If we hadn't automated things, we would have been in trouble if we got, I don't know, 10 requests a day for a developer account, right?
Right.
But now we have, lots and lots of people using StepSend, um, and an active community, and the issues we are addressing are at a different level, and so it's an example of how the scaling problem migrates from one place to the other, but the scalability of the system increases and becomes better at the same time.
Yeah. Yep. And just like with any of those axes that you're looking at, you can look at technical and non-technical solutions to
Mhm.
enable you to push that line further out before you need to do something,
Yes,
right? So,
exactly.
know, one example that we have today is if someone needs to change their API keys, they reach out to us because
Mhm.
that's not something that's exposed on our portal. But the solution to that, then, if that became an issue, so far it hasn't been a problem at all. But if that did become an issue, that would be something then we could make a product decision on to say, okay, let's create the capability in the portal for someone to just recycle a key and
Exactly.
you're done.
Exactly right. And that's the trade-off. The trade-off is, something that is service management becomes product feature, you have to do the work to make it a product feature.
Yep.
But as you do the product feature, the service management work decreases. So it's like the ski rental problem, right? Do you buy skis or do you rent them? And at some point, it just makes more sense to buy skis.
Yeah.
Right? Let me go on to the next topic. I just wanted to leave with a few kind of what I thought are pragmatic thoughts about scaling and building services that scale. The first thought is don't solve problems you don't have to. Make the design investment early. Think through what you would do if you had the problem and be ready to build the solution quickly. But make the build investment, which is the bulk of the investment, only when the problem is near at hand. Because 8 out of 10 problems, you may not get there for a while.
Mm-hmm.
And the second thing is let others solve non-core problems for you. Because there really are many, many, many scalability problems, and all the help that you can get will only help you make the system overall scale better. So we use, and we use services that scale. We make sure that they scale, and then we invest a lot in exploiting that capability as much as we can. And almost always, and we believe we are very good engineers. We can do anything reasonably well if we put our minds to it. But for many problems that are non-core to the StepSen business, the services we use do a better job than we ever will, largely because they invest more time and effort in understanding and building the solution. So the advice there is that if there's something that's not core to your business, then you should use a service. And if there is no service that is good enough, it may be worth revisiting your design to see if there's a better design that uses a service to do things that are not core to your business.
Oh, that's an interesting point. Yeah, I hadn't considered that. I think I've always been kind of leaning towards use a service when possible. I love not having to spin up machines for infrastructure, for example. I use the cloud services all the time, but I haven't reached a point where I've found that I need to spin up infrastructure. I should go back and think about my design rather than just jumping to that solution that says, okay, I can't use a service. I should just start to do one quick little pass through to say, maybe I could make a change that would make this work if I use the service.
The reason I make that point is that you're doing the ski rental problem in reverse in this case. So if you think about this, when you choose to build your own for something that's not core to your business, you're committing to endlessly pay rent to that service, to running that service. Instead of maybe rethinking and doing a one-time effort to kind of refactor your code,
to find a way to use something else,
and you find a way to use something else and be done with it. And after that, just it's not your problem anymore. And by doing that, especially when there's no end in sight, it is like committing to rent skis every day for the next 2 years. I mean, it just doesn't make sense. If you're going to go skiing every day, and you know that you're going to be skiing for the next 2 years, you might as well just buy your skis.
Yeah, I used to like to say this to the companies that I worked with: when you make that build it yourself decision on something that's sort of not core to your product, now you've decided to build two products. You're building your product and you're building the product that is that service that you should probably find somewhere.
Yeah. And that's I think brings me to the end. I'm happy to you should learn more about StepSen. We have several opportunities for you to learn. We have our blog, and we have things on stepsen.com. If you want to use StepSen, we have a very good set of tutorials and instructions to get you started. We have videos on YouTube, and our documentation is worth reading if you're interested in using StepSen. So there are there's a lot of information there. You can go look at all of these things, and hopefully you'll find something there that causes you to think about how to do things.
Perfect. Well, I think we probably got a little bit of time for questions here still. And we've got the chat open. Feel free to drop them in there. I'll start one off because there was one that I was kind of thinking about while we wait to see. Oh, we actually do have a question coming in. Let me answer this one quickly. Is Steps in a service that developers can use to outsource some of their problems? I think the answer to that is yes. That's kind of why we're in existence. Is that we think that a lot of what goes into building GraphQL is something that can be turned into a service, and you can essentially have a serverless GraphQL server that sort of takes care of all of the nuts and bolts for you, and you're really just designing your schemas at that point.
Exactly right. I mean, all of this is experience from building StepSend and other services like StepSend that both Carlos and I've had. And so none of this is just kind of, these are things that we've learned while building StepSend.
Sure.
And so all of these things are things that StepSend does, right? And
yeah.
We are a service, and we encourage you to think about us the same way that we think about external services, right? Is there something that I can get from this service that solves a core problem in a deep way, and they'll be able to do this better than we will ever be able to, because
I don't have to worry about scaling and all that stuff. Exactly. Right. That's exactly what we're here for. That was a nice one. So the other thing I was thinking, and this is just something that I know the engineering team has been working on, and I wanted to ask you how it fell kind of into your little 6-step plan. As we're building out support for subscriptions, that's like a whole new kind of traffic pattern. What does that fall under? If you were to look at that in terms of your approach to how you the scale axes, I guess. What is that? It's not necessarily traffic, because it's a little bit different that way.
So the way I think about subscriptions is that it improves it changes our request complexity, which is bullet 5 here. So a subscription is a much more sophisticated request than a query is, because it says, take this thing and run it again and again and tell me when something has changed, right? Or give me a stream of information about this thing. And that requires a runtime infrastructure that is very different. And in fact, in building our subscription service, we made several fundamental changes to how our runtime actually works, right? And we have support, for example, for WebSockets protocol, which is a protocol that we did not support before we started building subscriptions. And servers that serve WebSockets have different performance characteristics, need be tuned differently, need a different ratio of how much memory is allocated to networking versus how much is allocated to compute and all of that, right? So those sorts of things are very hard to get right. It's and we went through all of that in order to minimize the cost of our WebSockets service. And so subscriptions led to us to do a lot of design work in order to be able to serve things in the right way, with the same level of reliability, with the same kind of cost profile, and so on. And we are quite proud of how we've done all of that. And also, it's not something that everybody will be able to replicate, not because we are somehow better than anyone else, but it's just because we've spent the time to do it properly. So That's a very good example of what happens when the request complexity axis just changes
dramatically. Perfect. I had my own little scalability issue there. I don't know if you noticed, but something went wrong on my end, and I dropped out for a second. But awesome, that's great. Well, I think we're about at top time here. So again, I'd like to just thank everyone for showing up. Please do try the service and hit our website, sign up, give it a shot. If you have other questions about about GraphQL just in general or StepsIn in specific, please do hop onto our Discord channel. We're happy to talk about anything that you're trying to do or problems you're trying to solve. I love helping customers solve problems, regardless of what sort of technology is being used. So that's sort of the sole reason I get up in the morning, is to do that kind of stuff. So hopping into that channel and giving us a shout would be much appreciated. It's really terrific when we get to talk to people.
And thank you, Carlos, for hosting this sequence of seminars or chats. I think we've explored a lot of interesting topics. Not just
I would agree.
with me, but with all kinds of other visitors as well. Hopefully, we'll do something, slightly different but similar again.
Yeah, or dive deeper on some stuff. I think we've got a lot of opportunities, and if people have suggestions for that, let us know. That would be great. All right, I think that's it then. We'll say goodbye. Thanks all.
Bye now.